We're building a small pond or wetland on the Wine Cup Gamble Ranch near Wells, Nevada. The pond will provide water for livestock and for wildlife. A meadow is located on a slope of less than 6%. A laser level is set up to confirm that the elevation of the area does not change any more than 3 feet from the upper to the lower edge. A soil auger is used to drill a hole in the center of the area where we would like to build the pond. Water soon fills the hole, showing that the ground is saturated. A 100 series excavator with a thumb attachment on the bucket will be used to dig the pond. The excavator is walked over rangeland to the wetland construction site. The perimeter of the work area is marked using brightly colored plastic flagging. The machine begins by removing the sod of native plants. These plants will be set aside and they will later be planted in and around the completed pond. The sod from non-native plants is not saved. This will be buried as part of the pond construction project. Discussions are held with the heavy equipment operator to decide where each type of material will be stored, whether it's temporary or whether it's permanent. The long reach of the excavator actually reduces soil disturbance on the site. We're able to stay in one place and reach the entire project area. Following the removal of the topsoil and the sod, we will begin construction of a groundwater dam. A deep trench is dug around the lower 2/3 perimeter of the planned project area. The trench cuts through all organic layers, all layers of sand and gravel, anything that can carry water out of the pond underground. Soil is placed in this trench and it's compacted in layers. The soil must be high in clay, otherwise it will leak. The construction of a groundwater dam is critical to the success of the pond project. The groundwater dam prevents water from leaving the pond underground. It helps trap that water and pool it near the surface where it can be used by livestock and wildlife. The construction of the groundwater dam takes time. It's a series of steps involving digging, mixing of the soil, placing the soil that's high in clay back into the trench, and compacting the soil in layers so that it's impermeable. Many people want to rush this step or don't see a need for it. Those are the folks that will not have success with their wetland project. The bucket on the excavator is used to compact the soil in place. This groundwater dam is quite narrow. It's really only 1 bucket wide. If room is available, it is better to make the groundwater dam wider. I've made the groundwater dams at least 12 foot wide, and that way I can actually place the machine into the trench and compact a much wider area of soil, thereby guaranteeing the success of the pond project. The excavator reaches inside of the area where the pond is being constructed to remove soil that is high in clay. This soil that's high in clay is placed into the trench where it is compacted in layers. Soil that is low in clay is discarded outside of the pond area being built. This soil will later be spread and evened and made to shape and blend in with the environment. It is important to build a groundwater dam even if soil high in clay is not present on the site. One can take soil of the texture of silt loam or even sandy loam, mix this, and then compact it into the trench to form a groundwater dam. This restructuring of the soil will reduce leakage from the pond area and thereby allow water to stay in the pond for a much greater length of time. This pond being built is expected to fill with groundwater. The groundwater dam is often called a keyway or a core trench. It allows the groundwater to seep into the basin and stay in the pond area, providing water for livestock and for wildlife. The excavator operator reaches into the planned project area to remove the soil that's high in clay. This soil is placed into the core trench to make the groundwater dam. The process of removing the soil from the center ends up creating a basin for the pond. After the core trench is filled and compacted, we start removing soil from the center of the project area and spreading the soil around the lower area outside of where the pond is going to be built. Water can be seen entering the basin as the groundwater dam is constructed. No efforts are taken to compact soil in the basin. In fact, the opposite is true. We want to make sure that this soil is kept loose so groundwater can rise to the surface. The core trench for the groundwater dam surrounds the lower two-third perimeter of the planned wetland area. You don't want the core trench to go all the way around the planned project because that would actually block groundwater from entering the basin. We just want to keep that groundwater that enters the basin from leaving the basin. The ground is soft because the soils are saturated on this site, and that means that the operator is concerned about becoming stuck in the mud. The operator has to be very careful where to place the machine to make sure at least one track is on firm footing so that he does not become stuck. The region where this pond is being built is very dry. Precipitation or snowmelt are not enough to keep the pond filled with water. That's why it's important to find a site where groundwater is near the surface and to use techniques like the construction of a groundwater dam to hold the water that is underground so that it will pool and be available for a variety of uses. Now that the groundwater dam is completed, the excavator operator works his way around the outside perimeter of the planned project area. He works to reshape slopes and to create gradual slopes so the slopes are not too steep for wildlife to enter. The water we can see entering the basin shows that the groundwater dam is functioning as planned. Care is taken in deciding where the soil is placed that is removed from digging the pond. The soil is placed in areas where it's not readily visible. The soil is also placed so that it will not wash back into the pond if there were a flood or a snowmelt event. The rough and loosen technique is used to prepare the soils on the slopes for planting. We find that these soils are loosened and not compacted. They are more likely to grow plants and less likely to erode. The excavator operator works his way around the outside perimeter of the wetland being built. He's taking that soil from the center of the planned basin for the pond and depositing it as far as it can reach outside of the project area. The machine will then go around the outside perimeter and spread this soil and blend it into the surroundings. On the left, we can see a completed wetland basin that is filling with water. To the right, we can see the soil that's being removed. Digging a pond is much like removing a pie from a pie tin. You do this one slice at a time. For safety, high visibility clothing is worn so the excavator operator can clearly keep track of where observers are located. Elevation readings are taken using a rod and laser level to ensure that the pond is being built to the planned depth. The deeper you make the pond, the steeper the slopes. If the slopes become too steep, they won't be stable. If the slopes are too steep, livestock and animals will fall in and could drown. That's why I like to make the slopes of the pond less than 20% on the inside. So we use the laser level and the rod to measure the current depth and to find out, can we make the pond deeper without making the slopes any steeper than 20%. When building a pond in an arid region, attempt to find a location where soils are saturated. This will allow you to build a pond that will contain water year-round. Another consideration is erosion. Avoid building a pond in a gully or in a ravine or from a stream. All these sites require a tremendous amount of maintenance. Ponds built in these locations will soon fill with soil from heavy storms and snowmelt events. A spillway is built for the pond. The spillway is the pathway that water flows out of the pond under flood conditions or when there's snowmelt. The spillway is built on a gradual slope of 1% or less. The spillway is wide, at least 12 foot wide, and in some cases 20 feet wide. The spillway carries water out from the wetland in a sheet-like pattern. This will further saturate soils and actually create conditions where wet meadow plants can thrive. Much of the sod saved when we began construction is placed on the path of the spillway. This will reduce erosion and promote the growth of these plants that are desirable. Here, soil removed from building the pond is spread around the lower edge of the wetland area, and it is also loosened using the rough and loosen technique, so it will grow plants and is less likely to erode. The sod of native plants that was saved is now placed on the hillsides in the highly erodible areas, so they will be stabilized, look attractive, and provide great habitat for wildlife. It takes time to replant the sod, but it's worth it. It provides instant vegetation cover on these exposed soils. The excavator operator borrows sod from an adjoining site where we're planning to build another pond later the same day. The majority of the sod is planted along the inlet and the outlet of the recently completed pond. The bucketed excavator is used to gently push the sod into the ground. While the transplanting of sod can be done by hand, the excavator is far more efficient. The construction of the pond is finished. The basin is now filling with water. Note the low area where the person is standing. This is the spillway for the wetland. This is a pathway in which water will leave the pond. The exposed soils are now ready for seeding. It's also recommended that you cover the exposed soils with a thick layer of straw. The straw can be from wheat, it can be from barley, or from oats, or even rice. Now that the pond is finished, the excavator is loaded onto the truck and trailer. I encourage you to build wetlands or ponds on your land. It's possible to build one or more in a day. It's now possible to build a pond that should last forever. For more information, please read the book that I've written, Wetland Restoration and Construction, a Technical Guide by Thomas R. Biebighauser. Thank you. Here's how the ponds appear a few days after construction. Many thanks to all who helped with the construction of these ponds.